Yo, 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 yo! Alright, guys, this is a video for 1.4 literal equations. So let's get to it. So a literal equation is an equation where letters represent both variables and also the known constants. So literal equations a lot of times actually don't have any numbers in it. So a lot of times they're just formulas. But let's look at this. We're going to start super simple. So Janet wants to calculate the time it takes to earn a certain amount of interest on a principal amount in an investment with simple interest. What equation can she use? So here is the equation for simple interest. I equals PRT. I is interest, P is principal, rate is R, and T stands for time. Well, Janet wants to calculate the time it takes to earn something. So she is trying to figure out, okay, I want to calculate how much time it takes to earn a certain amount of interest. So she's trying to calculate the amount of time. What we're going to do is we are going to solve this formula for time. So we're going to solve this formula for t by manipulating the equation the same way we do it as if there's numbers here. However, we're going to do it and just get t by itself. So we're trying to isolate the variable t all by itself. So we're going to do it the same way as if they're numbers. So what I mean by that, this is all multiplication. This is P times R times T. So what I want to do is I want to get T by itself by doing the inverse operation. Well, because this is all multiplication, if I wanted to get rid of the P times R, I can divide by P and R. Because that cancels and that cancels. But whatever I do on one side of the equal sign, I have to do on the other, just like with the normal equations. So I'm dividing by P and R on the left side. The thing is I don't know what I is, I don't know what P is, I don't know what R is, so I actually can't simplify that anymore, so I'm already done. And I just rewrite the work that I show. This is why showing the steps in equations has always been so important, because sometimes when you don't simplify, you need to know how to show the steps. So I'm left with time is equal to the amount of interest earned divided by the principal and the rate. And there's nothing else I can do. I have solved for t in this particular formula, so I am done. So again, you're solving it the same way you've always solved equations. The only difference is that we can't simplify because we don't know what the values are, so we just write the work out as we normally draw it up. So here's another one. So I want to solve for y here. This one has some values in it. This one has some coefficients. This one does not. But they both solve the same way. So that's the point of having them side by side, is they both solve the same way. I want to solve for y. So if I'm trying to get y by itself, the first thing I would do on this left side is I would subtract 2x from both sides. So I'm going to do that. Because 2x minus 2x is 0. I'm trying to get y by itself, so I have to get rid of the 2x, and I have to eventually get rid of the 3. So I bring down what I have. I have 3y equals 12 minus 2x, or negative 2x plus 12. It does not matter the order I write these in. Okay. Now, I got to get y by itself. So, well, actually, you know what? Yeah, so now I want to get y by itself. So then what I'm going to do here is I am going to then divide by 3, because that's what I would do to get y by itself. Whatever I do on one side, I have to do on the other side. So I'm left with y equals 12 minus 2x all over 3. And I'm done. I have solved for y. Now, another way I could have done this, though, is this is really every single piece on the right side divided by 3. So this is also another way to write this would be 12 over 3 minus 2x over 3. I'm just taking this 3 and dividing each term by 3. Well, 12 over 3 is actually 4. So I could actually write this as y equals 4 minus 2/3 x, or 2x over 3. That either way, it doesn't matter. So I solved for y. Yes, there's two variables here. It's okay. I'm still using my inverse operations the same way I would with values. So I'm looking over here now, solving for y. It's the same exact process. The first thing I did is I got rid of this term over here. So I'm going to subtract hx. I don't know what the h is. It doesn't matter. Like, that's exactly the same process. Those go away. I still have this cy here. m minus hx, don't know what it is, so I'm just going to write it as m minus hx. Then I would divide by c on both sides, which is what we did over here. I'm left with y equals m minus hx all over c, or I could write it individually as y equals m over c minus hx over c. Either one of these is the correct answer. I think this one looks a little bit cleaner, looks a little bit easier, less intimidating, but they're both mean the same thing. And notice how that's the same thing as over here. Okay? So, let's see here. This one can be a little bit difficult, maybe, depending on, because I see now it says solve for y, but I have y's on both sides of my equal sign. So if I have y on both sides of the equal sign, we got to get to the same side. Okay? So this one can get a little tricky at first, but it is one that we'll show you and see how you get it. Okay? So the first thing, what I think I'm going to do here is I think I'm going to use distributive property, because I got y inside parentheses over here, I got y on the outside of parentheses. So let's distribute just so we don't have them right now. So I have y times a minus y times b equals c times y, plus c times a. So when I distributed, I did y times a. I don't know what the y or the a is, so I'm just going to write that down as ya. Yeah. Okay, because that's y times a. yb is y times b. cy, ca. So I'm just writing it out. Now what I want to do is I want to get y to the same side of the equal sign. I can easily do that by moving this whole term right here. So if I want to move all of cy, I'm just going to subtract cy on both sides. That goes away. All I have left is a ca on the right. I still have ya minus yb minus cy. Okay, because I don't know, I can't subtract it, so I'm just going to subtract. I'm just going to write it as minus cy. So this is the last, probably the most tricky part right here. So I want to kind of, let's do a refresh of something from a while ago. If I had something over here, I'm going to write 2a plus 2m plus 2x. What we did before was what was eventually at one point called, not at one point, this is what it's called, but what we've done before is what's called factoring out a greatest common factor. It's like the distributive property, but backwards. If we notice these all have a 2 in common factor of 2. So if I divided all of these by 2, if this was just an expression as is, I don't have an equation, but I wanted to kind of write it a little bit more simply. If I did all these by 2, I can put that 2 on the outside of the parentheses, because those cancel, cancel, cancel. So I'm left with a plus m plus x. But I bring the 2 outside here, because that's the number I factored by. So this is the same thing as this. They mean the same thing. So this is 2 different ways to write the exact same expression. I did the distributive property backwards. I just factored out a common factor, because I could do 2 times a is 2a, 2 times m is 2m, 2 times x is 2x. So when I have a common factor, I can just divide it out and bring it over just to rewrite it in a different way. Well, that's what I can do here. So since I have y times a minus y times b minus y times c, or c times y, they all have a y in common. A y is being multiplied by all of these, which means a y is a factor. So I can factor out a y, kind of exactly like what we did here. I can divide everything by y, but because I'm only doing it on the left-hand side, I'm just doing this to simplify this side. So it's really bringing it outside. And I'm left with a minus b minus c. I just did the distributive property backwards. Because if I were to, again, this is the exact same thing as this. If I were to do distributive property, this is y times a is ya, y times negative b is negative yb, y times negative c is negative cy, or negative yc. It doesn't matter which order I write it in. So I factored out a y here. So what we did is we had a y on the left side, the right side, and now what I've done is now I just have one y over here on the left side. So that's the hard part. Now from here, what I'm going to do is this is just y times whatever all this is. I can finally do the opposite of multiplication, which is division. So I'm going to divide by all of A minus B minus C. Divide by all of A minus B minus C. That all cancels. I finally have my y by itself. So the reason why I factored was because it got me down to just one single y. CA over A minus B minus C, and I am done. I solved for y. I get it. This is tricky. Factoring is tricky, but the reason why we factor sometimes is it consolidates and it lets us do this division right here. Okay. So here's what I want you to do. I want you to try to solve for y on your own. There's no reason not to try it. See how you do. So pause it, try it, see what happens. Okay, I hope you have an answer here. So I'm trying to solve for y. This one's, there's no factoring in this one. This one's a lot easier. So first, let's do distributive property to get that y out of those parentheses. So I still have x equals 3y minus 3 times b all over m. Okay, so I got 1y. That's nice. So now I can multiply by m. So I got to get rid of that denominator, right? I want to get rid of this. I'm just going to multiply both sides by m. So I'm left with mx equals, these cancel, 3y minus 3b. Okay, I can, there's a few ways I could go here, but let's just add 3b to both sides, because that makes that go away. That gives me with just 3y over here. I don't know what mx plus 3b is, so I'm just going to write mx plus 3b. Now I get to divide by 3. Y equals mx plus 3b, all divided by 3, so really this is all being divided by 3. Or I can write it all under 1, but the reason why I did it this way is because I see that these 3's are going to end up canceling. So I have mx over 3 plus b, and I'll write it as a capital B, so it doesn't look like a 6. So you have it. If you wrote it as mx plus 3b all over 3, that's fine. Okay. I just wanted to simplify that a little bit. All right. There we go. I think that's it. Is that it? Let's look here. Okay. This is your independent practice. So we're solving for y here. Now, one thing I want to point out is that is the exact same problem. I messed up somewhere. So I guess you guys don't have an independent practice. You're lucky. All right, guys. Don't worry about these too much. We're going to get a lot of practice in. So thanks for watching. If you have any questions, please let me know. Gordias out.